half-life is basically, we first talk about the definition. That is the idea that half-life is the time taken for half the nuclei of any radioactive isotope in sample to decay. Decay is a process in which elements are having unstable nuclei. They emit alpha particles, they emit beta particles, and their atomic number changes. This is decay. Now, the time in which half of the nuclei are converted into daughter nuclei, this is called half-life. So, the symbol is T half. X converts to Y. This is the decay process. If you take X as 100%, Y will be 100 out of 100. Y will be 50%, the new element, and the X will remain 50%. We start with the parent element and we end up with the daughter element. Now look at this. This table shows the time is 2 seconds. So 50 becomes 5, 25 becomes 12.5. This is how the time is becoming half. The mass is becoming half in a time of 2 seconds. In mathematical ratio, as you remember the geometric progression in ADMAS, this is like a geometric progression 1 upon 2, 1 upon 4, 1 upon 8. Why the geometric progression concept helps that this number will never become zero because you are having it. So T half is constant. This is the next concept. Half-life does not change with time. The nuclei keeps on converting into daughter. This is a flow chart showing every time it becomes the half of the previous, but theoretically, it will reach zero somewhere infinity. When you keep a radioactive isotope somewhere, it naturally decays. Half of it becomes X and half of it is Y. Then again X and Y. So gradually the share of Y will increase. A very technical concept is here that what if the daughter nuclei Y is also radioactive? So Y will further decay and Y will become Z. It will keep on changing. So then it will be a two half-lives in one series. Exponential decay curve. What is exponential decay curve? This is the exponential decay curve. This is again support of ADMAS. Being an exponential curve, it will not touch the curve x-axis, and it's showing a gradual decrease. And naught is the first number, which is the total nuclei in the start. This is the total nuclei. It becomes half, 1/4, 1/8. Now you see, this is the half-life, which is not changing. Half-life is constant. And just like reading median in our O-level maths, we can take the number, like here the number is 500. We half it and read it on x-axis. This is the half-life. Now, this is the shape. Now, count rate is decreasing and the background radiation is there. This is a very common trick which they always play, that when you do these calculations, whenever you are doing calculation, you will see that background radiation, background count is also there. But background should be subtracted before final calculation. What are the formulas? New number upon original number is equal to half power n. Obviously, for paper one, it doesn't matter much. But for general understanding, the formulas should be known. N is equal to total time. N is equal to total time upon half-life, where x naught is the initial reading and x is the final reading. Now, what x represent? Number of nuclei. It can be mass of the nuclei, count rate, activity. So these are the titles. Now, there are some calculations on half-life. These are past paper questions. We have gone through quickly. If you want to see any of the formula, you can note down if you want, or if you remember, then it's fine.
No, I remember. This was a good review. Now I have some questions that I marked.
Good. Actually, the audio was issue, so
the first,
you can't hear. Actually, something is. This audio issue is coming. Acha, let us see this question first orally. If we can do it, then I think you are saying that you have some questions, so quickly we'll go over it. The initial mass of a radioactive substance is 30 mg. Its half-life is 6 into 10 power 6, I mean 6 million year. Calculate this mass after a time of 20 million year. Now we have the initial number, which is 30, and half-life is given. So you will make a data. The initial number is 30, half-life is given, time is given. So you have to find X. What you do? You first find the number of half-lives, which are approximately 3.33. And then you put it in the formula and you use calculated function to solve to get the value of X after 20 million years. Now, this is a possible working. This is a possible working to find the half-life. I put my second example and then I will try to reset this audio issue. The initial mass of a radioactive substance is 100 mg. Its half-life is 4 hours. Calculate its mass after a time of 12 hours. These type of questions come in MCQs. Now, the time is 4 hours, the half-life. So, in 12 hours, 4 will appear 3 times. So, 12 upon 4. So, 100 mg times half-life is 4 times 12 hours. So, n is equal to 12 upon 4. So, there are 3 half-life. Then I put the formula and I'm getting X is equal to 12.5 milligram. Look at this working. So let me try to fix the audio because I can't hear you.